Okay, so now that we've worked through how to simplify radicals, today we're going to talk about adding and subtracting radicals together. And so there's a few rules we want to follow. So when we add and subtract, we only want to combine like radicals. That's kind of the big one. Okay, we only can combine like radicals. So what does a like radical mean? Like rads. They have the same index, so they're both square roots or they're both cube roots, and the same radicand, which is the number under the radical symbol. Okay, so that's what our like rads are. Now, the biggest tip that I can give you is to simplify everything first. And then go from there. Now, when we add, subtract radicals, we are really adding or subtracting the coefficients. Sorry about my cat. And we keep rad the same. And that this last piece will make more sense in a moment when we do some examples. So if you need to, go ahead and pause and get all of that down, and then continue the video to get down a few examples. So in terms of what this means, I am going to give a quick example of what we've seen in the past. So if I have 4x plus 5x, if I were to add those together, nothing's changing about x. I'm just saying I have 4 here and I have 5 here. So then all together I have 9x, right? So same idea with my radicals. If I have 4 square roots of 2 plus 5 square roots of 2, nothing's going to change in the rad 2. I'm just going to say I have 4, and then I have 5 more. So all together I have 9 square roots of 2. Okay, so similar to when I combine variables, I'm not changing, it doesn't become like x squared or anything. This isn't going to become square root of 4. Okay, nothing changes, but keep the rad the same piece. We're just adding up. Oh, I have 4 here, I have 5 here, I have 9 all together. Okay, so let's go through a few examples. 2 square roots of 45, subtract 2 square roots of 5. Okay, so simplify everything first. That's why we spent a couple days on simplifying. Simplifying here, so I can't simplify the square root of 5, but I can simplify the square root of 45. Now this 2 isn't going to go anywhere. I'm just going to simplify my rad here, right? And 45 is 9 times 5, which means it simplifies to 3 square roots of 5 minus 2 square roots of 5. This 2 that was out front, we need to now multiply by the 3, so that gives me 6 square roots of 5. Subtract 2 square roots of 5. So now that I've simplified, I can see that I have like rads here. They're both the square root of 5. So I'm just collecting the coefficient piece. I'm saying I have 6 here, and if I take away 2, well then all together I have 4 square roots of 5. Now we won't always have it so that everything is a like rad. So let me give you another example. Negative 3 square roots of 12 plus 3 square roots of 3 plus 3 square roots of 20. There's another example. Everything gets simplified first. So going down through, I still have negative 3 times the square root of 12 can be simplified. It's 4 times 3 if I break factor 12. Square root of 4 is 2, so it's 2 square roots of 3. Plus, can't do anything with this middle term, that's just going to stay the same. 3 rad 3 is still 3 rad 3. plus 3 times square root of 20 can be simplified. 20 is 4 times 5. Square root of 4 is 2. So this is 2 rad 5, simplifying my radical here. Now, anywhere that I simplified and I already had a coefficient out front, right? So my first term and my last term, I'm now going to go through and clean that up. So I have negative 6 square roots of 3 plus 3 square roots of 3 plus 6 square roots of 5. Now, these are not all like rads. I have square roots of 3's. These can be combined, but they cannot be combined with this rad 5. So what I'll do is I'll combine my like rads, and I'm just adding coefficients. So I'm negative 6 here, 3 here. Altogether, I have negative 3 square roots of 3. Plus, I still have 6 square roots of 5, and they can't be combined. So that's just my final answer. Okay, so let's look at a few more examples. And we'll make sure to do a couple with variables as well. So let's see. Let's do, I'm trying to look for a few that don't have the exact same. Well, let's do a cube root. So I do, ooh, sorry about my dog now. Sorry with the cat, now it's the dog. So I have, so if I do 3 cube roots of 48 plus 2 cube roots of 6, subtract 3 cube roots of 32. Okay, so right now these are not like rads. I need to go through and simplify everything first. And now they're cube roots. So I'm switching in terms of what number set I'm thinking of. So 48 is 8 times 6, and 8 is my perfect cube there. So I'm still going to have this 3 out front, and then my cube root will simplify into 2 cube roots of 6. Plus, I can't simplify this at all, so I have 2 cube roots of 6 here. Subtract, I have 3. Now this I can simplify, it's 8 times 4. This is my perfect cube, right? So 3 times 2 cube roots of 4. Okay, so same idea that when I'm simplifying, I'm just switching from perfect squares to perfect cubes now. So I have 6 cube roots of 6 plus 2 cube roots of 6 minus 6 cube roots of 4. So now I'm looking to see what I have for like rads. So same index, same radicand right here. These are my like rads. And I have 6 here, 2 here. Adding that together, I have 8 cube roots of 6. And I still have negative 6 cube roots of 4. And so cube roots, we're going to treat exactly the same as our square roots. Let me just throw another one up here without variables. So negative 2 square roots of 6. Subtract the square root of 54. Subtract 2 square roots of 24. Okay, so if you want, pause it and see if you can break that apart on your own. I'm going to go ahead and start here. So no perfect square, can simplify that first one. I'm going to keep it as is. 54, that's 9 times 6, so giving me 3 square roots of 6. 24, that's 4 times 6, giving me 2 square roots of 6. And notice here I have that coefficient out front. So look, we have all like rads, but we got to clean this up first. So that's going to give me negative 2 square roots of 6, subtract 3 square roots of 6, subtract 4 square roots of 6. They're all rad 6's. I'm just going to add up my coefficients. So negative 2, then negative 5, negative 9 all together, square roots of 6. Okay, let's look at a couple that have variable terms. So let's see, 2 square roots of 54x cubed plus 3 times the square root of 2x cubed. Okay, so on my first radical here, so 54 is 9 times 6. And that's going to give me the 2 still up front, 3, and then square root of 6. X cubed, just like before, we got to break that apart. So I can take the square root of x squared. That would give me 1x out front, and 1x would have to stay inside my rad. Plus 3, and I can't break apart the 2, so that's going to stay in my radical. And then the same thing here, x squared times x. I can take the square root of x squared. 1x has to stay inside. Now, what you'll notice here is after we've simplified, we don't have like rads. That's okay. So we've simplified it, and we're just going to have to leave it as 6x square roots of 6x. So 2 times 3 is how I get that 6. Plus 3x times the square root of 2x. Okay, those are not like rads, so I have to leave it here. What's inside the radical does not match. And let's look at a cube root one more time. So -3 cube root of 81 x cubed. Subtract 2 cube roots of 24 x cubed. Okay, so I'm going to have the -3. That's not going to go anywhere. Now 81 is a perfect square, not a perfect cube. So I got to switch to thinking about my cube numbers. So 8, 27, 64, and so on. And 81 is 27 times 3. Cube root of 27 is 3, leaving me with the cube root of 3. The cube root of x cubed, we can take, it would just give me x to the first outside. Subtract 2, right? That's not going anywhere. Now 24, when we think of cube roots, we would use the factors 8 and 3 to simplify. Cube root of 8 is 2, leaving me with a cube root of 3. And again, cube root of x cubed is just x outside that radical. So I'm simplifying here separately, simplifying there separately, cleaning it up, -9x, cube roots of 3, subtract 4x, cube roots of 3. Now these are like radicals because I have cube root of 3 here, cube root of 3 here, and I can add my coefficients because those are also like terms, right? So if I have -9x and -4x all together, I have -13x cube roots of 3. Okay. So now what I would like for you to do, you'll see on the next page, there's 6 more rads to practice addition subtraction with. So I want you to go through and try these 6 on your own using that first page of notes to help you. And then pause the video, do those problems, then play the video and just kind of check your work. Okay, so I'm just going to kind of leave this up here for a little bit and you can pause it. I tried to show all of my work so that if your answer doesn't match mine, you can maybe see where things went wrong. So our first 4 are square roots, just kind of checking your answers. Last 2 are cube roots. I forgot to write a negative and I started rewriting that one there. Then with our cube roots, again, only combine things that are like rads. And you'll get some more practice with this over the next couple of days as well.